Okay, I'm gonna pick up where I left off. Some call came through, so I had to stop short here. So we'll continue with problem number 5. And I left off where I had this information labeled in our diagram. And I was talking about how right here we have a 90-degree angle that's formed between the sides of this diamond or this playing field. And this line right here bisects this angle. So then this is gonna be at 45 degrees. Okay, so with the law of cosines, it's important to know that when you have two sides and an angle in between them, then we're going to be able to use law of cosines. So we're going to use law of cosines here. Now, I can label these sides and these angles however I want. So I'm going to label this one A, B, and C. So their corresponding or opposite sides are going to be A. B is going to be this one. And this one's going to be C. Okay. So now I'm going to use, since I don't know A is what I'm trying to figure out, then I'm going to use the law of cosines, which helps me find A. So that's going to be this one, A squared equals B squared plus C squared minus 2BC cosine of A. And I'm just going to plug in the information I have. So A squared, B we know is 60 feet. C is 43 feet. And then over here we're going to plug in 60, 43, cosine of A is 45 degrees. Okay, and then we're going to go ahead and calculate all this out. So when we calculate this, we end up getting, I believe is, let me check this out, 3,600 plus 1849 minus 5160 cosine of 45. And when you calculate all this right here and take the square root of A on both sides, or take the square root of both sides, you end up getting A equals 42.43 feet. So the distance between the mound and first base is about 42 feet. Okay, so this is your answer. Okay, so we'll move on to number 6, problem number 6. So problem number 6, they are saying we're going to use law of cosines. And another problem regarding softball or baseball. So this one, however, we're going to draw a picture like this. We're actually going to need to draw a smaller playing field. So this represents the softball diamond or the baseball diamond. Here's the mound. And for this problem, we're talking about a baseball that was shot out to midfield. So we're gonna use this right here to show that this was shot out all the way to midfield over here. Okay, so this was out here in midfield. Now it says that the midfielder threw it back to third base. So that means that from here he threw it all the way to third base right here. And so if you notice, we have a triangle that we can form from home base to third base, from third to midfield, and from midfield to home base. And the information they gave you is that this right here is 240 feet all the way from here to home base. And we are going to try to figure out this distance from the midfielder to third base. And they gave you this information, 60 feet is from home, the distance between each of the bases. And once again, this line right here that I created, the red one, bisects the angle, which is a 90-degree angle. So this angle right here is going to be, this angle is 45 degrees. Okay, so we have that angle. And if you notice, once again, we have two sides and the angle in between in this triangle. So we're going to use the law of cosines to find our missing length right here. I'm going to label this one A. I'm going to label this one B and C. So this side is going to be B and this one's going to be lowercase c. And we're trying to find what A is equal to. So I'm going to set up my law of cosines similarly to the previous problem. So we have A squared equals B squared plus C squared minus 2BC cosine of A. And I'm going to plug in my values. So A squared equals 240 squared plus 60 squared minus 2 times 240 times 60 cosine of 45 degrees. And when I calculate these out, I'm gonna get 835.32. And then I'm gonna take the square root of both sides, so I'm gonna get about 202 feet. Okay, so the distance between the midfielder and third base was about 202 feet, so that's how far he threw the ball. This is our answer right here. All right, now we're gonna move on to problem number 7. So number 7 is gonna be using law of cosines once again. In this problem, they're talking about a boat. So they said the boat is heading east, and then it said that it changes direction and starts heading northbound or north. Now, for this problem, it's a northward. For this problem, it's important to know that, like I mentioned before, just because they're heading northward doesn't mean that it's gonna be heading straight north. It might be heading at an angle. So for this problem, the boat could be heading northward this way, and until it got to point C. So in this problem, they didn't give you which points were A, B, and C, but if we label them this way, it really ends up being the same idea as if you were to label them with a different, in a different manner. So for this problem, they said that the ship traveled 60 miles due east. Okay, then it said that it traveled 80 miles in the new direction. And they said that once it got there, the distance between the starting point and the place where it ended is 139 miles. Okay, so we end up coming with this picture right here. So for this problem, we're going to use the law of cosines, but we're going to use the standard notation. They are trying to figure out angle B, so we're going to use cosine of B equals A squared plus C squared minus B squared all over 2AC. And we're going to use this to figure out angle B. So then we're going to plug in our values. So we have cosine of B equals 80 squared plus 60 squared minus 139 squared all over 2 times 80 times 60. And then we're going to get we're gonna get negative 0.97. So you should get negative 0.97. And then we're gonna take the inverse cosine of both sides. So we're gonna get b equals arc cosine of negative 0.97, which is gonna equal about 166.15 degrees. Now, the problem is asking, describe the bearing from point B to point C. So the bearing from point C to B to point C is not 160 degrees, 166.15 degrees. We have to think of this in terms of bearing. So bearing starts from due north. So in this case, if we draw the line that represents due north, then we can see that the bearing is actually going to be from here to here. So just this small angle right here. So in order to figure that out, we can just subtract 90, because this angle on the left side of the line of bearing is 90 degrees. So this line that I drew represents north and south, and we are going to be looking for this angle right here. So in order to do that, we subtract. So we say 166.15 minus 90 degrees. That leaves us with 76.15 degrees. So your answer is 76.15 degrees from due north, or, so you have to put it like this, from due north, or you can write it as north 76.15 degrees east, just like they've been giving us this in the word problems. So now this is telling me that the ship was heading north, but 76.15 degrees to the east, or you could say 76.15 degrees from due north. Okay, so either of these could be your answer. So that was number 7. And now number 8. Alright, so number 8. This problem also will be using law of cosines. In this problem, you had another word problem or situation about a boat. So this one similarly is a boat that was heading east to point B, and then northward to point C, and then the distance between the beginning and the end, they said, is 56 miles. The distance between B and C is 30 miles, and the distance between A and B is 40 miles. So they wanted, again, the bearing, to describe the bearing from point B to point C. So it's going to be very similar to our previous problem. So I'm going to use cosine of B equals A squared plus C squared minus B squared all over 2AC. We're going to plug in our values. So we're going to get 30 squared plus 40 squared minus 56 squared over 2 times 30 times 40. Cosine of B is going to be equal to negative 0.265. So when you calculate all this out, you get negative 0.265. Then we're going to take the arc cosine of both sides, or inverse cosine, same thing. So we get negative 0.265, which is going to be equal to about 105.37. Okay, so this is actually not our bearing, but we can figure out our bearing by thinking about that from due north, we are going to be talking about this angle right here. So we need to subtract 90 degrees because we don't need this angle on this side.